Okay, hi guys, welcome to this YouTube channel where we talk more about web development and Python programming language and also other programming languages. So today we are going to talk about Python numbers. So in our previous videos, we talked about types of numbers. We talked about integers. We have different types of numbers. We have integers. So we have floats. So today's video, we are going to talk about numbers and how Python interacts with numbers. So let's begin with an integer. We can say integer a is equals to 1. So 1 is an integer because it's a whole number. So an integer is a positive or negative whole numbers. So let me write that here. An integer is a positive or negative whole number. So then let's move on to floats. So a float is a number with a floating point. A floating point is a decimal number. So 1.2 is a float. Okay? 1.2 is a float, and because it's a float because it has a decimal number. So that's what we call floats. We have integers and floats. So we can do operations on the numbers. Numbers are commonly used to do operations. We can do operations like a plus 1. What do you expect us to get? Let me print that so that everyone can see a plus 1. So what do you expect us to get from a plus 1? So python app.py. So we get 2. You can do arithmetic operations using Python on numbers. We can say 1 times 3. Let's make 1 2 so that we can see where. So we get 6. So 8 times 3 is equal to 6. We can do all types of operations on Python numbers, and you can also do operations on floats. So let's see. We got 3.59999. So we can do operations on Python. So let's move on to a concept called augmented assignment operator. What is this? So let me show you something, some trick. What if we want to increment a by 3? So we have to do a is equals to a plus 3. So we got a plus 3. This is not Pythonic way of doing things because we have a simpler syntax and easy and concise. So what do you do? So what if I told you that this one is exactly equals to this one? So number 15, line 15 at line 15 is exactly equivalent to line 17. Only that line 17 is simpler and more concise. So this is what we call augmented assignment operator. You can do multiple things. You can multiply. 8 times is equals to, you start with the operator. Start with the operator. Let me write here. Start with the operator, then operation. Operator, then operation. So that's what you should be working on. So operator, operation. You can do multiple things using Python numeric numbers. You can do, so let's do something like b. Let's make a3. We can do division. We can say a divided by, let's make a10. We want a bigger number to use here. So we want a times a divided by 3. So let's see what we get here. So a divided by 3, you can get all that. We have another operation called modulus. So the modulus returns the remainder. Modulus returns the remainder. So what does that mean? Remainder. Hey, don't worry, but I hope you got the what I meant. So it returns the remainder. So what does that mean? So a modulus 3. What is 10 divided by 3? What is remain? What remains there? So that's what it asks us. We get 1 because 3 times 3 is 9, then we only have 1 remainder. So that's what we call the modulus operator or modulo. Anything. You can do anything. It's called the modulus operator. Yeah, you can do any sort of operations on Python. So let's move on to we have some built-in methods. We talked about methods last time. So a method is just a function that is inside an object, and you say that in Python everything is an object. Functions are objects. We have classes are objects. We'll come to talk about that later. So we can do something like print round. We want to round something, rounding off. This is a built-in method in Python. We want to round 1.2. What do you expect us to get? So 1. It rounded off to the nearest whole number. Okay, so 1.6. What do you expect us to get? Got 2. So that is the round function. Okay, so we also have another one called absolute. So we can say ABS for absolute -20. So what does the absolute do? The absolute returns the absolute value, and the absolute value is a value without a negative sign. So just removing the negative sign, you get the absolute value. So you can see how math is complicated. We have things like, what if you wanted to round off 1.2 to the nearest whole number, b? We wanted to round it off to the nearest whole number that is above it. So what if you want to round off 1.2 to 2? Instead of going to the nearest whole number, you go to the nearest, not the nearest, the highest whole number that it can get. So 1.2, what if you want to return it to 1.3? Of course, we have a way to do that. So Python chips in some built-in methods to help us, but those methods are not present here in the current file that I'm in. They are defined in another file, and that file is called a file that is defined outside what you are working on is a module. So a module is a file that has some Python code. So we have this module called math module, which has mathematical functions to help us do mathematical arithmetic operations. So you have to import it. You import it like this because we are saying this at the current file we are in. We don't have access to the function. We have to import it before we use it. Yeah. So to use something, so a module is simply a file. Let me write that here. A module is simply a file that has some code. So this is a module. We import that module. That module has functions that can help us, and those functions are called method because they are defined inside an object. Okay, and we can access them. So let's do something like print math dot. Now whatever we get here, we can use it. We have this ceiling. This we can use this function math dot ceiling. What does math dot ceiling do? It rounds off a number that is passed into it to the nearest whole number that is the highest, like it's the topper whole number. So what if we want to round off b? B is 1.2 to the ceiling. We get 2 because to the ceiling means to the highest whole number. We have another function that can help us do the round off to the lowest. What if we have 1.7? When we do math.flow, this function helps us round off to the lowest whole number. So come here and do the lowest whole number, which is 1. Simple. So we have more functions that can help us do multiple things together with Python. So let me show you I'll share this link with you so that you can get access to whatever thing I'm trying to show you. So we have math.seeding. So this is the Python docs. You have the math.seeding. You can read everything about those functions here. You have the math.factorial floor. I won't go deep into them, but just know that we have these inbuilt functions in the math module, and they can help us do multiple things. Okay, so the next concept we are going to move forward to is a concept called type conversion. What is type conversion? Okay, let me write it here so that you can have access. So we have something called type conversion. What is type conversion? Simply as it is states, type conversion is converting something from one state to another. So let's begin with something to do. So let's say user input is equals to input, and then you can say what's we talked about escaping characters in Python yesterday. What's your age? Uh-huh. So we can do that. What is your age? Then we talked about this. I want to create an a prompt from the user asking them what is their age. I want to show you what type conversion is. So these you are seeing here, these are escape characters. I'm escaping this character because a quote is defined. A quote is used to show strings in Python. So by escaping that quote means I need that quote inside my string. Whatever I escape an n, this means a new line. So that means the input won't be at the end of the screen, but it will be in a new line. I want to show you how type conversion can help us. So we have the user input, and then we can print something like we talked about formatted strings yesterday. So if you didn't go through that, then you have to do that. We can tell the user you will be. Then we talked about formatted strings. I want to go through them again, but in case you need. So what are we doing here? So let me finish writing this. Next, yeah. I want to create a function. I want to create a Python function, not a function, a Python code that will take the user's input and then will print the input they will be, the age they will be in the next year. So we simply take the user input, what the user inputs, and then add one. Then you can say years. Okay, simple. Let's try running this code. What's your age? You can see now I'm in a new line because I escaped the new line character. What if I didn't escape that? I would be here. I don't know whether you can see here. At the end of this question mark, that's where I would be. But I don't want that to happen because I'm a Python developer, and as Python developers, you have to come up with solutions. So let's say my age is 30. Oops, our program crashed. What happened? So can you read here? So you can see type error can only concatenate strings, not integers. So we talked about strings yesterday and the other days. So today we are talking about integers, and then you can only concatenate. What happened here? What is happening is that the user input is always a string, and you know you cannot add a string to an integer. It's illogical. Can't happen. So what do? That's where type conversion comes into play. Okay? Type conversion simply says convert this into another format. We have types of type conversion. We have this function helps us to convert into an integer. Okay, we have bool, which helps us to convert into a boolean. We'll talk about that in a second. So let me show you. We call the int function and say convert this user's input into an integer. And then whatever we get from that integer, we can add that into one, and then our program will work as expected. So what's your age? My age is 30. Hey, you'll be 31 years next year. That's cool. Let's try that again. We run that Python again file. What's your age? This time I'm 40. Let me say I'm 40. You'll be 41 years next year. Hey, congrats. You made your first Python workable program. Very easy. just by knowing how to work around with these functions and these methods. So that's what we call type conversion. So on type conversion, let's talk about the Boolean type conversion. So let's say, so let's start with we want to convert into a Boolean. So we can print bool. We call the bool function and pass it whatever you want to check. So Boolean returns either true or false. Let's give it an empty string. We talked about strings, hope you know. So an empty string is false. So that's where we get a concept called false values. False values. Now we have seen the first one, which is an empty string. Empty string. Let's go on. We have another one called a list, an empty list. So let's clear this and then run the code again. It's false. So we have this one is called a list. We'll talk about that later. Empty list. Okay, that's an empty list. Okay, let's see what one does. What if we do one? So one is true. What about two? Two is true. Okay, what about zero? We have false. So zero is also false. We have another primitive data type called none. Okay, we talked about primitive data types. If you have not, go check out the playlist and then it will be easier for you. So none is false. So these are called false values. How can we use these false values? Let me show you. Okay, so we can say name. Name is equals to my name, Web Tech Guru. Okay, so if name print, we talked about formatted strings, how useful they are. So you can say print hello, and then we can add the name, and then we can cross off that. Then else we can print hello stranger. Okay, nice. So we can come here and clear and see what we exactly get. Hello real web tech guru. That means this name became true. So that means that these are just the only false values in Python. Empty strings, empty list, and an empty dictionary. Okay? Empty string, empty dictionary. Yeah, so those are the empty values. The empty values are false. So everything else is true. You can see my name is true. What happens here? So the program comes and evaluates if name. What's name? So name has a value, and if it has a value, then it is true. And we know if a logical expression evaluates true, whatever is inside there is printed. That's why we got hello and then my name. What if we add an empty string here? What if hello stranger? What happened? So name evaluated to false. We have just talked about this. So name evaluated to false, and if name evaluates to false, what happens? We go on to the next block of code. This one is not evaluated because if if is false evaluates to false, this one is never evaluated. But if it evaluates to true, we go on. That's why we skipped this one and came here to the else statement, printed hello stranger. You can see how that useful is. Instead of doing something like if the length of the name is greater than zero, something of that sort, greater than one, something of that sort. So we did something simpler to help us achieve the same result. Okay. So let's do some exercises to ferment what we have just talked about. And yeah, that's it. Okay. Yes. So if you say if name, then I'll add this one into a git gist and then you can check from there. So let's do some simple tasks here. So write a Python function. So write a Python function to program to convert degrees to radians. Simple. Okay. We have our degrees and our expected result is this. What do we do? We have just talked about the math function, the math module. We import that, take whatever is in there that can help us convert the degree into radians and then do that. So what I will do is just import math, and after importing import math, then we can print something like print math dot. We want a method that will help us to convert degrees into radians. So we can find the radians method. This one, we have it here. So talk about the what do we want to convert into radians? We want to convert 15 into radians. Just as simple as that. Okay. I ran the wrong file, don't worry. Python exercises.py. So we got the same answer that was expected here. This one. The same as this one. Okay. So let's do the last challenge. Write a Python program to convert radians into degrees as easy as it is. We want a program to convert radians into degrees, so we can look for that. Can simply look for that. This one, didn't I get it? So we grab that function and then pass it whatever you want it to convert into radians. Okay. We got 29.278. Is it this one? Yeah, we did that. That was sure bet. Okay, thank you guys for I'll end up that video. I'll end this video there. Thank you for listening, and if you have just followed up until this point, kindly leave a subscribe, leave a like button, hit that like button, and support this channel. Thank you, and I would like to hear your feedback on the Python numbers, and good luck. Thank you.